I got something fancy for Christmas this year. This is my new TIG welding machine, which I've already christened in typical practical engineering fashion. I'm a welding newbie and currently absorbing anything I can on the subject, so while I learn, I thought I would take the time to boil down some of that new knowledge and share it with you. Now, this is welding for the guys and girls at the front of the class who never set foot in a machine shop. You know who I'm talking about, the marching band members, the geeks, the nerds. We're not going to obfuscate things with bumble fudgery and Canadian syllogisms. In other words, if you already nail the keyhole on your root pass, this video might be just a bit elementary. I'm Grady, and this is Practical Engineering. On today's episode, we're talking Welding 101 for hobbyists. For our purposes, we'll define welding as a way to join metals using fusion. That fusion is what makes welding different than brazing or soldering. When you're joining metals, you have two parts, the base metal and the sometimes optional filler metal you use to reinforce the joint. With brazing and soldering, the heat is only enough to melt the filler metal and not the base metal. This is the metal equivalent to how most glues work. With welding, on the other hand, the base metals are melted so that fusion can occur. The two metals actually become one. Set your spirit free, it's the only way to be. Little Spice Girls reference for you. In general, and compared to other common building materials, metals have excellent mechanical properties. They're hard, tough, strong, and durable. As someone who, and I hate to say it on a welding video, occasionally works the wood, even I can admit that metals are a superior material in many regards. So you can see why it would be advantageous to have a way to connect them together, especially if you can do it in such a way that the joint isn't the weakest part of your assembly. That's the goal of welding, and luckily, this is not something reserved for industrial factories and machine shops. From my own experiences so far, welding is something that you might be able to do yourself as a hobby. And stay tuned till the end for some tips on getting started. Welding requires two essential ingredients, heat and protection from the atmosphere. The heat, of course, is necessary to melt the pieces of metal being welded so that they can fuse together. The shielding is necessary because molten metals easily oxidize and absorb atmospheric contaminants. These impurities will weaken a weld or prevent good fusion altogether, so some kind of shielding is usually required. Now, there are a lot of ways to make heat. That's actually a fundamental law of the universe, but it's also true in the more specific sense here. So, as you can imagine, with only those two basic requirements, a litany of welding methods have been developed using different permutations of heat and shielding. Luckily for me, as the writer of this video, only a few of those methods are widely accessible to hobbyists. Today, we'll talk briefly about 5. The first is Oxyfuel welding, also known as gas or torch welding. In this method, the heat comes from the combustion of a mixture of pure oxygen and some other gas, usually acetylene. This combination creates an extremely hot flame which can exceed the melting point of most metals. The shielding comes from the flame envelope, and gas is generated by the combustion, mainly carbon dioxide. With oxyfuel welding, you use the torch to generate a puddle of molten metal. With your other hand, you add filler metal to the weld. It's a very simple process and one of the oldest methods of welding. Advantages are that it feels really awesome to hold an oxyacetylene torch, it doesn't require any electricity, and the torch can also be used for other purposes like cutting, so you can get a lot of use out of a single tool. Disadvantages are that you have to have 2 high-pressure tanks of flammable gases nearby, and the torch is kind of unwieldy, which leads to slower and less consistent welding. For the next 4 types of welding, the heat comes from generating an electrical arc between an electrode and the metal. You've got the short I-sound nicknames, stick, MIG, and TIG, and I'll sneak flux core in next to MIG, since you can usually use the same machine for both processes. Probably the most common type of welding is shielded metal arc welding, also known as stick welding. This process uses a power supply to maintain an arc between the electrode and base metal. In stick welding, the electrode is also the filler metal, and it's surrounded by flux which melts during the welding process. When an arc is struck, the heat generated melts both the base metal and the electrode, causing them to fuse together. The flux coating also disintegrates, generating both a shielding gas and slag, which absorbs impurities and creates a protective covering over the weld as it cools. Stick welding is so popular because of its simplicity and versatility. Constant current power supplies are fairly inexpensive compared to other welding machines, and stick welding can be performed in almost any environment, including underwater. Disadvantages are that it only works for certain metals, mostly iron and steel, and that it can be a fairly messy process with lots of molten spatter and fumes. Next up are the two wire feed welding methods: gas metal arc welding, also known as MIG, and flux core arc welding. Both MIG and flux core welding use a constant voltage power supply to generate the arc, and a wire feed mechanism for the electrode, which is also the filler metal. Just like in stick welding, the arc melts both the electrode and the base metal, allowing them to fuse together into a weld. For MIG, the shielding comes from an inert gas, that's the IG in MIG, that surrounds the arc during the weld. Usually the gas shield is a mixture of argon and carbon dioxide. As its name implies, flux core welding uses a tubular electrode with flux in the center. The flux shields the weld by generating gas and slag, just like with stick welding. You can use both an inert gas and flux cored wire, a process known as dual shield welding. Gas metal arc and flux core arc are two of the fastest welding methods in terms of deposition rate, since you don't have to stop to get a new rod. MIG and flux core welding are also considered the easiest methods to learn because there are fewer variables to control during the process. MIG is generally an inside process since wind can blow away the shielding gas, but flux core can be used in most environments just like stick welding. Finally, we have gas tungsten arc welding, or TIG welding. This process is much like torch welding. In fact, the business end of a TIG welder is also called a torch. When TIG welding, the arc passes between the electrode and the metal, but unlike in the other processes we've discussed, the electrode doesn't melt since it's made of a tungsten alloy. Instead, filler metal is added to the weld puddle with your other hand. The puddle and arc are shielded from the atmosphere by the IG and TIG, usually pure argon gas, which is focused around the weld by a ceramic cup. TIG is the most precise of the techniques we've discussed because you have greater control over the length and current of the arc, the rate at which filler metal is added, and other important variables which can affect weld quality. That control also makes TIG the most appropriate method for welding thin materials and non-ferrous metals like aluminum, magnesium, and even titanium. For the same reason though, it's probably the most challenging process to master and usually the slowest. To get started, welding requires some equipment, most importantly a welding machine or Oxyfuel setup. Many machines on the market today can perform more than one welding process, so you don't always have to choose a single one. However, like many hobbies, there's some rabid brand loyalty when it comes to arc welders, so make sure you choose the right color. You don't want to come home with a Lincoln only to find out that your wife only goes for Miller guys. And don't forget safety. Like any hobby that involves searingly bright lights, molten metals, and high voltages, welding can be hazardous. Consider the dangers before welcoming one of these machines into your home. And if you're budgeting to get started in the hobby, don't forget all the safety gear you need to buy as well. Like I mentioned at the start, I'm new to welding as well, so I'm far from your best resource on the subject. Luckily for all of us, there are a few people on YouTube putting out incredible educational content for free, two of whom were kind enough to share footage with me for use in this video. Jody from Welding Tips and Tricks makes awesome videos about welding, including beautiful arc shots, so you can see exactly what's happening when he welds. This old Tony makes extremely well-produced machine shop videos that are big on fundamentals. Do yourself a favor and go subscribe to both of these channels. I promise you will not regret it. Huge thanks to both these guys for letting me use some of their footage. Finally, thanks to the sponsor of this video, Great Courses Plus. If your New Year's resolutions included learning a new skill, consider this. At the Great Courses Plus, you can get unlimited access to a massive library of video lectures by award-winning professors from around the world. They don't have a welding course yet, but I love this one on Everyday Engineering by Dr. Stephen Ressler, which turns a technical eye to the things we use in our everyday lives. Click on the link in the description or just type thegreatcoursesplus.com/practical to access high-quality courses about science, math, history, literature, or even how to cook, play chess, or become a photographer. Thank you for watching, and let me know what you think.